Good morning. We're back. So I realized yesterday, when I set the stream, it just said the title was like Aladdin Passion live stream, and a lot of people were joining then, and we're like, well, what is it about? And I thought I had changed the title, but I didn't. So this is learning about PyTorch Lightning part 2. If anyone's gonna join, then you know what's up. So yesterday, it was just a chill kind of me going through the basics of PyTorch Lightning. Let's see. So we did this. Oh, right. tmux. There we go. This is what's nice with tmux, by the way. So if you SSH, like I did now, you just SSH into your machine. When you're in your machine, you just do tmux and you attach to the session you created, and bam, you're back at it. So this is exactly where we left off yesterday. And I took this basic. By the way, is this working? Let's see. Maybe there's I hope this is working. All right, I'm just gonna assume there's no one here. I don't know. All right. Yeah. Well, anyways, if anyone's gonna join, I guess later on, I'll go through what I did yesterday and I guess come up with some sort of plan for today, because let's see, I just want to make sure that everything's working. All right, yeah, we're live. Okay. Oh, it is working. Nice. Okay, now I can see the chat. It wasn't working before. Yeah, yesterday I went, basically I'll show you. So I guess many of you are familiar with PyTorch Lightning, but for those of you who aren't, let me just go through sort of why you would want to learn it in the first place. So my idea, or sort of why you would want to learn PyTorch Lightning, is there are multiple reasons, but one of them is that the boilerplate code you write will just be standardized, and it will take care of all of that stuff for you. So it eliminates a lot of code, a lot of potential mistakes you can do when writing. And so it makes like a standard template of how you should go about writing your code. And so when you read others' code that also use Lightning, it will be sort of easier to read it. That's one of the things. But then if you just look at the functionality, I think multi-GPU training is really nice. You can just change to use TPU if that's what you would like. You can, what else did we see yesterday? So what else was cool? Yeah, like easy logging, just a lot of stuff are easier. Like you can do if you just write in bare bones PyTorch and you change the precision, it's going to be really annoying. Like here you can just do precision equals 16 and it's super nice. You can just change the number of GPUs you want to run on, 2 GPUs. No, I want to run on 4 GPUs, and so on. And then you have extra functionality as well. In this, you have a profiler. You can add some extra features that are nice, that you can overfit on a couple of batches first before you do any training. And after that, you make sure that works, which is sort of a really good basic sanity check. Then you run a fast dev run, which runs through your entire sort of training, evaluate, and testing loop with a couple of batches really quickly, just to make sure that there's no bugs in any of the main components. So yesterday we took some basic code for MNIST, and we just converted the code to use let's see. And we just converted that code to use Lightning. So we converted the module to a Lightning module. We defined all the components inside that. We defined a training step, a test step, and a validation step, and a predict step. So this is right. This is what I learned about yesterday. Remember, this is me learning about it now. So I don't know if I can explain all of these things. But the goal was sort of to learn about it, and then as I learn more, I'll make more structured and refined videos. So this is just for fun. If you want to join and watch me fail, then that's cool. But there will be more refined and clear videos with better explanations. That's the goal, at least. But yeah, so what's the goal for today? I was thinking, I'll continue with I don't know the best way to learn PyTorch Lightning. But I was thinking of, I was reading the documentation yesterday, and we went through pretty much all the basic skills. So we might take a look at the intermediate skills, and then, I don't know, try to rewrite some more advanced code maybe, and then maybe take a look at these tutorials as well. But yeah, it's going to be a slow, just a chill stream. Oh. By the way, tell me if that's too loud for you. I tried to configure the audio for you guys yesterday. I like that they've tried to make it as user friendly as possible. That, the fact that they take the time to, make these videos and stuff. I think that's really helpful for people wanting to learn. So I think that's a big pro as well. I'm not sure where. I guess these are the tutorials. Yeah, I'm still a little bit overwhelmed with this stuff. Like, we got it working, but I definitely am not comfortable with this way of writing right now. So I guess it's just going to take some time, and as the more times you do it, it's probably going to become easier. So PyTorch Lightning in normal copy. I'm not familiar with normal copy. What's that? Is that a library? I haven't heard about that. Oh, what's a good plan? Ah, goddamn, I don't know where to start on this. Like, there's so many stuff you can do. Maybe we can just check out these these videos until I figure out what I want to learn about, because I don't know, like there were so many things here. I guess you could go into either it might be best to just do another one so that just practice the same thing as yesterday, and do that on another example. That could be a good idea. Or to maybe go deeper into these callbacks might be a good idea to learn about how the callbacks work, because they seem to be really important. Also learn about some extra features. I mean, I learned about these things yesterday, which I thought were awesome. These fast dev run overfit batches and profiler. Maybe one could learn how to use them a little bit better as well. Like run the profiler to make sure that the data loading is fast. And you know, basically what I've done so far, like my type of, this is how primitive my workflow is. So right now I'm like, let's see, this is like my workflow now. So I look at my GPU and I'm like, all right, what's the temperature and what is the usage? And if the usage is low, then I know that the data loading is taking too long time. So that's, I think using these profilers can be a pretty good idea. You can check it in a better way. But yeah, so I'm thinking until I figure out what I want to do, but I'm thinking probably we'll take some other code. Yeah, I don't know which code though. And I want to learn how to do it with TensorBoard as well. So I want to have TensorBoard, how to run the logs and see everything on there. And then, so let's see, maybe there's some better code we can work on. So like it was a long time since I did, maybe we can do like the VAE thing. Maybe we can take this VAE and try to, because this is a pretty one I did recently. Maybe it's possible to take this one, try to convert it to PyTorch Lightning code instead. That could be a good idea. I guess you can do this in a single one, train, yeah. Actually, let's do copy. All right, so this is the plan. Take this today, take this code and rewrite it as we did yesterday to PyTorch Lightning for more practice. But before we do that, let's try to learn some stuff. We'll go through these videos and check it out. What's up, guys? Nice to see that people are joining. Yeah, well, the from scratch videos, it's like when I've done a project that I've wanted to learn something, that's when I've done those from scratch videos. So right now, like my goal right now is to, these last couple of weeks I've been trying to improve my workflow. So that's been for me to work through a SSH machine and set up sort of tmux and NeoVim and stuff to just have a better development sort of workflow. And then what did I want to say with that? And yeah, my goal right now is to continue that by doing PyTorch Lightning stuff to improve my coding workflow as well, and learn a little bit about some libraries. And then my goal is to do some projects. So we'll see. Maybe I'll stream doing projects as well in the future. But right now it's just, it's just chilling and then learning about some stuff. So I'll continue them when I have something to share. I'll always share if I'm doing something that I think could be valuable to others. Then I'll share it. But I haven't done any from scratch lately that I think would be helpful for people. The theme, I followed this guy on YouTube, and he basically helped set up a Vim workflow. So I just stole his. His name is, I think it's spelled, I'm gonna butcher the print, but it's called like this. So if you just search Hosen NeoVim, you can watch his video on how to set up a similar environment. All right, let's get started on this. So we'll check out the intro. Whoa, that was loud.
Hey guys, I'm William Falcon. I'm the creator of PyTorch Lightning, a lightweight framework for deep learning research. In this video series, we're going to go through all of our features and all of our trainer flags so that you can accelerate your research. Some of those features are training on GPUs, multi-GPUs, multiple TPUs, gradient clipping, early stopping, gradient accumulation, and so on. There are about 40 of these that we're going to walk through. The main API that you'll be working with in Lightning is the Lightning module. Lightning module defines a full deep learning training system. A deep learning system could be an individual model, so it could consist of layers and activations, or it could be a collection of models that then define a broader system, like a GAN, or BERT, or an autoencoder. A Lightning module groups together all methods related to training a deep learning system so that the system can be self-contained. It's a subclass of nn.module, and it's basically just a collection of methods. Those methods are your training loop, the validation loop, the test loop, the optimizers and learning rate schedulers, and then the computational graph definition. For this video series, we're going to be using this simplified autoencoder here on MNIST just to illustrate the basic concepts. But if you go to our repo under examples or our bolts library, you can see many more advanced use cases there. An autoencoder consists of two networks, an encoder and a decoder. The encoder takes an input X and then projects it down to a low dimension, and then the decoder tries to reconstruct X from that low dimension. It's a very simple process, which we define in this Lightning module. In the init, we pass in the two different networks we want to use, an encoder and a decoder. In the forward step, we define how we want.
By the way, just making sure you can hear this. Let me know if something is if it's off, if there's no audio or too loud or anything. I'll change it.
Encoder to work during inference. In this particular case, we're going to give it an input image, and it's going to give us an embedding for that image. In the training step, we define what happens during the training loop. We start with a batch, and then we run it through the encoder, extract a Z, and then run that Z through the...
The only thing I don't like about this, by the way, when I did this yesterday, is that if you look at the training step and the validation step, and now you can't see this so well, but it's basically the same code copy-pasted. So you do XY batch, XView, encoder, decoder, MSE loss, right? This is pretty much the exact same on the training step and the validation step, and also the same on the test step. So it's copy-pasted code 3 times. And that's not really nice to watch, right? It's kind of messy. And also, if you want to change this, then you need to do it on 3 different, I guess, one time and then copy-paste. But I tried to do it this way. Oh, okay, never mind. I tried to define a separate function that's a common step that sort of includes all of these 3. But I don't know, there might be a better way.
Extract the reconstructed image. And then we calculate the MSE for the prediction and then the input image. And then we send that loss back to the system. The validation step and test step do exactly the same thing as a training step. But in this case, I'm also choosing to log the validation and test loss. The final method is the configure optimizers. For the autoencoder, we're going to use a single optimizer, and we're going to pass the weights of both encoder and decoder, which in this case are defined as part of this broader module. So I can simply say self.parameters to encompass both set of weights. You'll notice that the Lightning module doesn't have anything about looping over epochs or datasets or setting your model to eval or train or enabling or disabling gradients. The Lightning trainer automatically handles that for you, which means that your Lightning module can be focused strictly on what you're trying to solve scientifically. The next part we need to define is the dataset. In this case, we're going to use MNIST, which are images that represent a digit between 0 and 9. The dimensions are 28 by 28 pixels with only a single channel. We're going to be using...
Yeah, that's what I was thinking as well. Yeah, like one step and then... Yeah, I agree. I think that's a better way of doing it. That's what I tried to do yesterday. Yeah. Working environment using GitHub. Yeah, like I might do few, like right now I'm learning my working environment. So, you know, if you are a Vim user, you'll see how bad I am. I'm just getting started. So I'll think when I get more familiar and I learn my setup a little bit better, I might make videos, to how to set up a good workflow, and you know my thoughts and pros and cons on different things like VS Code or Vim or stuff like that. But right now I don't have good sort of my ideas right now are not very established, or I'm sort of changing my thoughts very frequently. So as I get more familiar, I'll share that.
3 splits of MNIST: the training split, validation split, and test split. The Lightning trainer operates directly in PyTorch data loaders. You can pass in a train data loader or validation data loader or test data loader if you have them. Throughout this video series, we're going to be focused on the trainer and the flags that you use to control how the trainer works. You can use the exact same flags and features on any complexity model. If you ever need something different that the flags don't provide, you can always override a hook or implement a callback to modify the functionality for whatever it is that you need. So in summary, you need 3 things. 1 is a Lightning model, 2 is a data set, and 3 is the trainer. Once you have those 3 pieces, you can just call trainer.fit and Lightning will take care of the rest. You can see the Lightning gives you a quick weight summary, which you can toggle on or off. And then the progress bar tells you how far you are into training. You can find a link to the notebook showing this model in the video description.
That was a good overview. So the second here is automatic batch size finder. That feels like a very niche. maybe that shouldn't be the second video. But yeah, let's learn about it.
Batch size, which lets you automatically figure out the largest batch that you can fit in memory. Larger batches can help you train faster and can give you better estimates of gradients. Most of the time...
Let's try that out then. Let's go back. CD basics. Lightning module, simple CNN. Let's do... We'll do true on that. Ooh, did we get print or anything? No? Let's see. So what batch size did they use? Oh. What just happened? Okay, missing logging folder. All right. Restoring stays from checkpoint. Cool. The direction pad has changed. Okay. Won't be reloaded. All right. Dir pad has changed. All right. Your val loader sampler has shuffling enabled. I like these as well. I mean, this is nice. I don't know if PyTorch does that as well, I guess, but it's nice either way. I don't know what batch size they used. Did they say that here? Because that would be good to know. I guess they didn't. Maybe there's like a verbose. No. Is there a verbose? Invalidate? No. Okay, so there doesn't seem to be a verbose version. I guess we'll just watch the video.
You know what batch size to use, but in certain cases, you want to just maximize the batch size because you want to decrease the training time or because you need more samples to be able to have an accurate gradient estimate. In that case, you can let Lightning figure out the batch size for you. If you want to let Lightning automatically find this for you, set the autoscale batch size flag to true. Lightning has two algorithms to determine the largest batch size for you. The first one is called power. It starts with a batch size of 1 and raises it to a power of 2 until you run out of memory. The second mode is bin search, which stands for binary search. In this mode, Lightning will use binary search to find the largest batch size for you. For Lightning to set the batch size for you, you need to have a self.batchSize attribute in your Lightning module or a self.hparams batch size in your Lightning module. The recommended way to use this is to use the .2 method of the trainer, where it will run the algorithm for you, tell you what the batch size is, and then in subsequent runs, pass that into your data load.
Okay, so I guess we need to, let's remove this then, and let's remove multi-GPU just for, well, actually you would want to have multi-GPU, but let's just do this first, and then we can remove the precision thing as well, I guess. And default root directory, we can remove that, and checkpoint path. All right, so now we should get, hopefully we'll get that it runs trying 2, 4, 6, 8. Nope. Come on. What? How did you do that then?
So that just batch true. Lightning has
Autoscale batch size true.
Algorithms to determine the batch size of.
I did not get that. Okay. We'll just try to remove as much as possible and see. I'm not sure. Doesn't seem to be working for me. Maybe it has to do with the workers or something. Oh, but wait, we are setting the batch size here. I don't know if you can do this though. No. I'm confused. All right, let's go back.
And raises it to a power of 2 until you run out of memory. The second mode is bin search, which stands for binary search. In this mode, secret runs.
Oh, okay. We need to do tune. I missed that part, so that's cool. I thought it said trainer on the video. Yeah, it does. That's confusing. So it should be trainer.tune instead of fit. That's confusing, bro. The batch size finder cannot be used with data loaders passed directly to fit. All right. Please disable the feature. Does this work? All right, so I mean, it needs to have the data loader. Like, how does it know? Yeah, thanks for the help. I saw it now. Batch size in H params. I will look at the tune part. Well, we did do this. So we sent in the model, we sent in the train data loader. What error did we get? Max epoch was not set. GPU available but not used. All right, we can do that. So we'll do devices. Trainer.tune. The batch size finder cannot be used with the loaders passed directly to .fit. Okay. Okay, so I guess you need to define, but it does take a data loader here. So how does this work anyways? Oh, here, nice. I didn't see these yesterday. Hands-on examples. That's kind of what I was looking for yesterday. So this is a lot better, actually. This is what I would make videos on. I think these are the best, that you can see a full example, that you can just see how everything's used. Activation functions. These aren't sort of too basic though, maybe? Or... these are a bit confusing because I think these would be pretty scary for someone just wanting to learn about Lightning, because you are teaching about multiple topics and you're jumping between topics as well. Like graph neural networks, a lot of people haven't worked with that, and vision transformers and all of that stuff, self-supervised learning. It would be cool just to see on a basic example and how you convert the code. I don't know. I didn't really like the auto scale batch size thing. It was a little bit confusing, to be honest. I mean, I don't know how to use it, because all right, so I mean, Yeah, I don't know. That was not. Maybe I'm just confused over it. I don't know. But that was. We'll skip that one because I didn't really like it. Mm-hmm. Wow. Okay, that's lagging. This is another thing I noticed yesterday, and honestly, this is kind of annoying. Their website is super slow. This is kind of one of the big criticisms I guess I have right now. Come on, bro. All right. I just want to learn about this. Come on. All right. Maybe the automatic learn rate is better. Let's try it.
The best learning rate for your particular problem. Learning rate is probably the most important hyperparameter that you have to tune for your neural networks. Once Lightning finishes this process, the output will be a graph where you can see a plot of learning rates versus losses. And then you can make an estimate as to where you want to start with your learning rate. While Lightning finds the learning rate for you, it will then set it into your Lightning module so that by the time configure optimizers is called, it will use the correct learning rate. Remember that although your model is initialized when you pass it into .fit, the configure optimizers call is lazy, which means that it won't actually be called until it's needed for training. So the recommended way to use the learning rate finder is to run
auto LR find. Let's try that then. Auto select GPU, true on that.
trainer.tune, which will find the learning rate for you. And then once that's complete, then run trainer.fit with the correct learning rate in subsequent runs. If your Lightning module doesn't use the property self.learning_rate, then you can specify what that
maybe that's the mistake I made previously. You send in the batch size and the learning rate to the init of the Lightning module. So it might have been my fault then. Let's see. So we send in, as we did here, batch size, and learning rate, or just LR. And then syntax error. What? Oh, right. So we need to do, let's say we do it in the beginning then. Batch size, LR. And then what did he do? At the end, after defining these, I guess it shouldn't matter, but like this, self.batch size, self.learning rate. Maybe that's the difference. All right, well, that worked then. Learning rate set to this 0.05. Wow. Damn, I did not expect that high of a learning rate. All right, let's do the auto batch size as well now, if it works. No. Oh, we need to do tune. Oh, we did do tune. All right. Okay, I still don't understand the auto scale batch size, but the auto learn rate seems to work. But I don't know if that's actually like... Okay, now it's found 0.02. Okay, let's do max steps equals 1,000 instead or something. A 0.05 trainer.fit.max steps equals 100. I did change it though, but maybe it's here. I do like the idea of doing like a trainer.tune and then you do a trainer.fit, right? I think like that would be pretty ideal, I think, but it needs to work also. And I feel like this is like really high. You need to have a learning rate scheduler for sure. I mean, you can't use that learning rate for long. Probably, I mean, that's a really high learning rate. So maybe, yeah, I don't know. All right, but it did work at least.
Then you can specify what that property value is in the flag. So you say auto find LR equals whatever I call my learning rate in my module.
Okay, that's good to know.
If you don't have a logger, you can use lrfinder.plot and it will plot the learning rate curve for you where x-axis is the learning rate and the y-axis is the loss. You should not pick the lowest point in this curve, but instead you should pick the point highlighted in red. This is the point returned by the LR finder. Currently, this only works for a single optimizer, and we will be adding support for multiple optimizers in the next few months. For most problems, it may be impossible to estimate the learning rate up front, so don't expect this algorithm to solve all of those problems. Instead, you can use it as a ballpark estimate where you should start to look for an actual learning rate to use in your problem.
Yeah, I mean, and Saba says, let's be honest, is PyTorch Lightning really necessary or is it just hype around the library? I think that's a valid question, but I don't think the question is if it's necessary. I definitely don't think it's necessary, but the question is it going to make the workflow more convenient? Will you make less mistakes? And does it allow for more and better flexibility once you've learned and set it up? I do think that's the case. From my experience yesterday, so right now I don't have a strong opinion on it, but my thoughts right now is that it's going to be a beneficial thing to use in general. I think it will save time. I think it will be allow for to focus on a development and quick iterations of experimentation, and that's what we want, right? We want to become more productive in our workflow. So I don't think it's necessary, but I do think it can be really beneficial when it comes to sort of training stuff faster. This is one of the key things why I want to use it, is to be able to set these multi-GPU accelerator and then strategy for these multi-GPU setup. That can be quite annoying to do in bare bones PyTorch. I'll be honest though, this is not really helpful because here they just do trainer, but I guess maybe there's something I'm missing. You need to, maybe this is what I'm missing. Okay, so how does this work then? I mean, I would also like to have the plot. So is there a way to get that? So my idea is like this. I would like to have set the precision, everything like this, have my callbacks, all of that stuff. And then I would like to do a trainer.tune. I would like to get the batch size and the learning rate. That's what they think are the best. And then do trainer.fit on that. I mean, that would be pretty nice if it worked, obviously. That's the big question, if it works. Both, if it works, what did I do now? If it works to get a good learning rate, first of all, and then also if it runs. So incorporate the data load into your Lightning module or Lightning data module. Okay. How do you do the data set then? I mean, this is a Lightning module. So this is my class for the Lightning module. You can also set up the data loading here. We can try that. Maybe that works. It also seems that you can do a data module. I mean, it doesn't seem like you're doing much here. Like all you're doing is you have the data set, but really you're just defining the data loader here. And then you're setting args.batch size. You're doing that. I mean, that doesn't seem that different. I can do that. Yeah, we can do that. I feel like that should be in some of the skills they have here. The basic add validation set. We've done all of this. So let's see. Enable script parameters. You pre-trained. Understand visuals. Okay, that's maybe an intermediate. No, okay. Yeah, okay. That doesn't seem to be it. I wonder where we are now. So we're in the docs and we're under managing data. Where is that? Managing data. All right, anyways, seems to be what I want to do. So let's try and do that. We'll set it in the end. It's kind of big. It's gonna get a lot of code in this Lightning module, but I mean, that's fine, I guess. So we'll do train data loader. We'll need to set up our data sets before. So let's just take all of this. Oh, that was bad. I shouldn't have done that. Let's see. 30. Let's go here. Now we should do, no, like this. Oh God, this is bad. Okay, wait. We do, let's see. We want to take all the way up here to that, and then we want to take it. We want to go to the top, go down, And we want to put it, I guess here is good. So we'll take this thing. Maybe we will define this outside. So we'll do this, put it here. Again, that was bad. You should do this. There we go. And now we'll go down. We'll take the train loader. And I guess here we should do args. Where does args come from? I mean, in the example here, args.batch size. All right, we'll try it and we'll see. We'll get an error. But so here we'll do args.num workers. Pin memory. We don't have to do this now. So we'll just do this. We'll do okay. I mean, this is not indented properly. We can do this. Let's see. Right. Bam. Formatted nicely. You saw that? That's Vim for you, bro. That's Vim. I don't know if you saw that. That was pretty fast. Not gonna lie. So you do. I've mapped it to my leader key and then B. So I just do boom, and then you have black formatting instantly, which is pretty sweet. So if you do something like, I've had some problems with this because I think it realizes if you're doing it by yourself, but try to do this, boom, put it all in an ugly line like this. And now we get some errors though. Okay, like that. I don't know what I just did though. Let's see, let's go back. So here, if I do this, and this is ugly. Okay, and then if we do space B, boom. You saw that? That's clean, man. That's clean. You should definitely use that. Use black if you install it, and it's a pip package, pip install black, and use it. It's a pro tip. Especially if you're lazy and you can't format code, then it's pretty nice. All right, but let's see. So we did the train loader, bam. What else do we need to do? Return loader. All right, so we'll return it. Return train loader. I don't know why I did all of them first, because it might not even work. I really hope this works. Oh God, otherwise we did all of this for nothing. Invalid syntax. What's the syntax error? All right, no syntax error. No, we do have syntax error. What did I do? Go back. All right. No error. Return train loader. I'm confused. Return val loader. Huh? What did I just do? I have no idea. Boom, no error. Am I dumb? I have no idea why it's not. Let's just do this for now. Oh, that was wrong. Oh, there is a syntax error now. All right, we'll do this. And then we'll just have this, and we'll return the train loader. Oh, maybe it shouldn't be called train data loader, val data loader, test data loader. Okay, but anyways, okay, we'll return the train loader. We'll remove the trainer.fit here, and we'll do trainer.fit here on the train loader. And then we get a syntax error again somewhere. This is closed. This is closed. I'm really confused over these syntax errors I'm getting. Line 17, unexpected indent. $173. Okay, I don't know. Let's just try it. I don't see an error, so. But there is one. Oh, there was an extra space there. Right? So now it should work. Oh no, okay. Let's just do this. Boom. Now it works, right? And then we'll do trainer dot fit. Close it. All right, let's try it. Args is not defined. Yeah, that's what I thought. I mean, where does this args come from? I mean, okay, so I want to use it with the auto find batch size thing. So if I want to do it with that, then please disable this feature. The batch size is going to be used with data loaders passed directly to fit. Please disable the feature or incorporate the data loaders into your Lightning module. That's what I've done though. Okay, nice. Cool, we got something to work. Succeeded. Trainer.fit stop. Max steps reached. Batch size succeeded. Okay. Batch size 16,000 succeeded. 32,000 succeeded. Wow. Okay. Guys, we're going to use a batch size of 32,000. Come on. What? Batch size of 32,000? It's over 9,000. Wait, what? Learning rate stopped due to diverging loss. Finding best learning rate. Failed to compute the suggestion because there are not enough points. Increase the loop iteration limits or the size of your data set selected. Okay, guys, I don't know. I'm about to give up on this tune thing, okay? I don't know. I mean, I really want it to work badly, but, you know, I have to see the reality of the situation, and it's not working. It's not great, not terrible. Let's put it that way. Oh, God. Okay, so, I mean, what do you do with that? It doesn't... First of all, I have no idea why you would put batch size to be 60,000 just because it can fit on the GPU, right? I don't know. I don't know. Maybe it's just me, but I always do like learning rate 3 minus 4, always the Karpathy constant. This is where you start. Batch size 32. If it doesn't work, you look at the loss. I do learning rate 1e minus 4. Well, the batch size is kind of what fits in memory, but let's just say as default 32. If that learning doesn't work, I'll just do 5e minus 5 or something, and then I'll do 1e minus 5, and then I'll run it at that for a long time, and then I'll do 5e minus 6, and then I'm good. But obviously there are better ways, or I use a learning rate scheduler, but yeah. So increase the loop iteration limits. I mean, what you could do, I guess, is maybe it's too much to do both of these. Maybe okay, so what's the problem here? The problem is train.fit stop, max epochs. Oh, max epochs 5 reached. Oh, okay, wait, okay, so maybe it's my fault. We'll do this. We'll do 100. It can run 100 epochs to find the learn rate, okay? That's a lot, but hey. Okay, so it will use a batch size of 48,000, which is almost the entire data set. So it's using like complete gradient descent on the entire data set. And I guess we'll have some patience, okay? We'll try it out. And then maybe it works better on another more realistic application than this on MNIST. But taking this long to find the learning rate is ridiculous. I mean, this is MNIST we're talking about. This should be like seconds. Yeah, this is not gonna work. This is too long. I feel like it should find it in 100 steps, probably. Someone asked if I know anything about key point matching between images. That's a context switch, but let's see. I think you should check out the SIFT detector. This one, maybe start with something like this. Or I looked into this a long time ago. I think I used SIFT. I can probably look at my GitHub repo, but I think I used Civ. God, I don't remember this actually. But yeah, maybe that has. Check out SIFT and then work from there maybe. Yeah, you're right. You if you use the thing we did, then we shouldn't. Oh, it's gonna take exactly as long. So let's do 10 steps. I mean, I agree that that's really low, but on the other hand, it can't take forever. Yeah, ransack was the word I was looking for. Uh, yeah, sift with ransack is a good starting point. There are better methods for sure, and there are even deep learning methods for that. But yeah, I mean, in most scenarios, you want to start with the basic stuff, and then if that doesn't work, then you'll increase the complexity of it. And I think even OpenCV has some nice implementations that you can just use. Yeah, I don't know about this, guys. I don't know. Does for those of you, if there's anyone watching that actually uses PyTorch Lightning a lot and knows about it, is this just like for show? Like, is this actually usable? I feel like it's not right now, but maybe I'm using it wrong. So I don't want to give up on it, but it's not great. So I'll just, yeah. Yeah, I'm from Sweden. All right, we'll skip the tune part. I don't know until we learn how it works exactly. I don't think this is a great thing to use right now. And if that's the case, then I don't know why I should set up my val and data loaders like this. The Lightning data module. No, I used, so they said either put it in the Lightning module or put it in a Lightning data module. I figured why not just put it here, but maybe it's better to do it in the PyTorch Lightning data module. All right, so this is what we did in regular PyTorch. And the equivalent data model just organized the exact same code. I mean, I don't have anything against doing it this way, so we can do that. Maybe that's better general structure for it. We'll do data directory. I agree. Yeah, I definitely think I didn't like doing it this way because it's a bit messy. So I agree. Yeah, I think we should definitely put it. We should put it in a separate module, I think. So let's do data directory. Let's just do the default on this. Why do we have a predict data loader? Or the example they gave here, you do val data loader. I don't know why you should have a predict data loader. I feel like these three should be enough. I don't know why this is here. Oh, that was a mistake. All right, so let's comment this thing because we're not going to use it. And then we'll remove the data loading stuff here. All of this, remove. We'll have the data module. We'll set the batch size. Fine, we'll use it this way, but then I don't know what the tear down is. I'll remove it then. Yeah. All right, that seems like a okay setup. And then we want to have teardown used to clean up when the run is finished. What does that mean? Clean up. Okay, there's a lot of functions here. I'll just remove it for now because I don't know what I'm going to use it for. Okay, and then how to integrate it after I have it. Let's see. Oh, that was a mistake. Go back. So PyTorch Lightning data modules. Here they define a Lightning module. Data module. Okay. We have prepared data. didn't even use prepare data, but yeah, I guess this is where we can download, setup, loads the data set. Yeah, that's what we did. And then we specify the loaders. That's what we did as well. Below we define the same model. Okay, and then init the data module. All right, so init the data module, we init the model, and then we do the trainer, we do trainer.fit, and then we send in the data module that maybe we can just do, let's see, so we can do, we'll comment out that, and then we'll do data module is MNIST data module. Maybe Copilot knows it, so we'll do cool. Maybe that works. Yeah, let's try it. MNIST is not defined. All right. Datasets.mnist. So we'll do mnist datasets.mnist datasets.mnist. MNIST has no attribute data dir. Yeah, I mean, we remove that, so yeah. What did we put before then? So we did, okay, dataset. All right, so we'll do root is equal to dataset. Just don't want to re-download it, so root equals dataset. Root equals dataset. Right, we need to do a transform as well. So we'll do, okay, dataset, transform. How did I do that? Oh no. Okay, let's just go to the top. No, let's do this. Take this. Okay, that should be it, I think. But what did we miss? So we did self.mnist. Yeah, this should be self.mnist test. Okay, cool. Cool. Nice. So this works now, which is really nice. So we have all the stuff here. Wonder if it also integrates with, I feel like this should be maybe be better with the tune thing. Okay. And if we do this, does this also work? We'll just stop it. I think 512 is too large. And we're also starting to get errors here from like to 1,000. Let's see. Up to 1,024, everything was okay, I guess. But then after that point, we started getting error messages that the number of training batches 27 is smaller than the logging interval. All right, so what if we do log every, we'll do 1 here. Yeah. I guess it can sometimes be helpful, maybe. I mean, now we're doing it this way. We can get the initial learning rate. I'm not even sure where I set the learning rate here. And it says we should use 0.06. So if we do something like, now we set the batch size, right? Where did we set the batch size actually? Is that here? Okay. So saying we should use 0.05. I was thinking if we change the batch size now to something like, just to make sure that it actually does something that makes sense. Batch size. We'll change this to 128. Oh, 0.05 still. Let's do 1,024. Yeah, I don't know. Does that make sense? You should decrease the learning rate if you increase the batch size. I don't think that's right. Shouldn't it be the opposite way? So if you put a batch size of 8, you should put a very low learning rate, I think. Here it says 0.05, but if you do 60, or if you do 10,000, does this make sense to anyone? See, now it's set to lower. I just have a feeling like, shouldn't it be the opposite way? If you have a larger batch size, you should have a stronger direction, and you should be able to move towards that direction faster. Yeah, I don't know. I don't know, guys. I'll remove this thing. I don't like it. Don't like it. So let's just yeah, I won't use that until yeah. So we'll remove auto learning rate, log and step stuff. We'll use the callback. We'll learn about callbacks later, but for now we'll just use early stopping. We'll do accelerate GPU, and this is a good thing to do. So what you can do is overfit batches first. So if we just run that, okay. All right, so we need to do trainer.fit. Okay, so how do I do the testing stuff also? Okay, train.fit model and DM, but we also want test model on test loader from data module. Oh, you can do that. Maybe that's nice. Yeah, that's my thought as well. Larger batch size means larger learning rate, but the estimate learning rate did the opposite, which is strange behavior, I feel like. But so nice. This at least works. So I guess this is nicer. All you do is you set up a data module, you do data module, you send in the data module, and you do that on a test set as well, and it just figures out which one you want. So yeah, I guess that's nice. I would like to have, so if we train this now on just 10 epochs, will this be, will it also evaluate on the val loader? That's the question. Yeah, it will. Nice. Cool, that's nice. I like that. Nice stuff. All right, so I'll show you what I mean. Okay. We'll see. I'll try it again. Yeah, I'm new to streaming. Sorry. I'm trying to just share my thought process of whatever I'm doing. Yeah, I'm not sure about the behavior of the batch size and the learning rate. I mean, I don't know if I trust this enough to use it. It's definitely not working out of the box to use the learning rate and the log scale thing at the same time. Yeah, I'm working on it. I'm practicing. So right now it's like, I really want this learning rate finder and the scale batch size to work because it would be awesome. But right now I'm thinking, all right, you can try the auto scale batch size to see what fits in memory kind of, and then use what you think is sane. So in this case, I think the batch size is like 512 would probably be okay. And then we run the tune for getting the learning rate. And in this case, they find 0.006. And then we just use that as our default. I think that would probably be a good option. We can try it by doing, I don't know, let's say we're just going to train for 3 epochs. I don't know if this is a good sanity check, but I'm thinking we'll do max epochs 3, and then we'll do what I would have used as default. So that would have been batch size 32, learning rate would have been 3 minus 4. So we'll do that. And we'll see what we get at the end of 3 epochs. I guess it's not fair comparison though, because now, as you can see, it's going to take a longer time than if we use batch size 512 probably. So yeah. But anyways, we'll see if this is a good idea. So if we use that, and the batch size, we'll set that to 512. Okay, so after 3 epochs, we got 97% accuracy. If we use the one batch size and the learning rate they find, yeah, we do get a little bit higher, and it's a lot faster. So I guess, I don't know, maybe it's a good idea to use it, I guess. Yeah, okay, we'll use that. I just don't think you can use them at the same time. I use this one first now, and then I just use that to get an idea of what batch size I can use. I set that manually, and then we do the learning rate find on that. So yeah, that's a okay setup. Let's go back to watching. We watched the first 3, so let's go through the next, I guess. These are so short. Wow. Okay.
It's common in deep learning that your gradients may trend to 0, which is called vanishing gradients, or they might trend to infinity, which is called exploding gradients. This happens as a side effect of backpropagation, where you might multiply many things that are just above 1 together, which means that you will trend to infinity, and many things that are just below 1, which will trend to 0. And this will make your training unstable. If you want to track the infinity norm, you can set it to inf. Lightning has a flag called gradient clip val, and it's set to 0 by default. If you've identified propagation through time, a number of 1,000 steps, you can process it in chunks of 5 by setting this value equal to 5. Make sure your batches have a time sequence dimension, and Lightning will take care of splitting your batches across that dimension. You can, of course, override how we do that splitting in case you need to control it. The flag so that you don't incur the cost of downloading that data or processing it every single time. That means that on every single epoch, we're going to shuffle the data and feed it into the training loop. If you want to change that behavior and force Lightning to reload your data loader on every single epoch, you set this flag to true. You would do this if your data is constantly changing or if you're using it in something like a production system. Flow of your code execution, you can plug into random places in that execution and execute arbitrary code. This means that you have full control over any point in the training system and can design self-contained programs that encapsulate a full set of functionalities on its own. The advantage of callbacks is that it decouples a lot of bespoke functionality that does not need to live in your Lightning module, nor your trainer, nor your data modules, and can be shared across other projects. For example, the early stopping and the model checkpoint are callbacks. With callbacks, you can do basically anything you can imagine. Use the callbacks argument to pass in a list of any callback that you want to use. You can design any callback that you want and add custom functionality using our callback API. There are over 40 different hooks that you can use to implement a callback. A hook is simply a function that will be called at some point during the training execution. Callbacks are really flexible and you're really just limited by your creativity. If you want to see a lot of examples of callbacks, look at our sister library called PyTorch Lightning bolts. So for example,
PyTorch Lightning bolts, let's check it. Deep learning research and production toolbox.
in our bolts library, we have a callback called confuse logic where you can basically figure out how to change an input as to trick the neural network to misclassify it. This is done by taking the derivative of the output of a logit with respect to the input just to maximize that via gradient ascent.
Okay. We already used this one, I think.
And that gives me a tensor scalar. What will happen once there hasn't been improvement in 3 evaluations. You can sum every single submodule, but it's going to give you the high level number of weights per major unit of your model. If you want to see the full description of your weights, you can set this to full. The full flag will print the summary of all.
Oh. What? Doesn't exist? Weights. That's kind of bad, no? So we did a trainer, weight summary, full, and trainer got an unexpected keyword argument. Oh, is it model summary now? Model summary. Okay. Print line weight summary. Okay. So we have, okay, so we have 80 parameters in a conv1 and 1.2 thousand in conv2. Is that accurate? I guess. We have 1 and 8 channels and kernel size 3, so yeah. That could be correct. All right, cool. That's nice to know.
Models and all submodels as well. If you don't want to print a weight summary, set it to none.
It's kind of just a little bit bad that I guess they change a lot. But I would have hoped that when they make these videos, I think it's been on 2 videos now that we've watched, that they've changed the name of stuff. So like this weight summary doesn't exist. It's enable model summary, I guess. So it's a little bit confusing. I don't know how long this was, but this was 1 year ago.
Only to the if you want to disable the progress bar, you can set this to 0.
Andre, if you increase the batch size, basically we compute a more accurate gradient and the updates will be larger, but also this means a higher chance of overshooting. So this is why the learn rate is decreased. So this is against my intuition, which is that if we use a larger batch size, then basically we know that the direction is, we know that we're going in a better direction towards the global minimum. So that means that if we're more confident in that our direction is correct, then we can take a larger step towards that. But if we use a smaller one, there's a lot of stochasticity, so we have to use a lower learning rate. So yeah, I'm not sure, but it did seem to work at least. So I don't know. I'll experiment more with it.
Lightning has a profiler to help you identify bottlenecks in your training. Set profiler equals true in your trainer to enable the basic profiler. This will give you a high-level description of method calls and how long it took to make those calls. If you want to have a more detailed description where it's analyzing each frame, you can enable the advanced profiler. In this case, you can import the advanced profiler and set the property profiler to the advanced profiler. This may slow down performance, so you want to make sure you're using profilers just to tune your models and to calls profiler to help you identify bottlenecks in your training. If you want to have a more detailed description, the basic
profiler equals true. Profiler equals true has no. Okay. Profiler. I know we got this to work yesterday, so
profiler. This will give you a
that doesn't seem to work. All right, so we can see here train data loader.next takes 12%. Let's say that we are making a mistake. So let's say we go to the top and we go to data loader and we change number of workers here to 0. Oh, num workers. We'll change this to 0, 0. Shuffle equals true. All right, so this is obviously a mistake. Wait, what just happened? All right. So there we go. What? Okay, so now we change the num workers and we can see that, all right, so we can see that the percentage of our time is spent 54% on the data loading, which is a lot. So then maybe our thought process is, well, that's a lot. So let's go num workers and let's change this to 6, and let's change this to 2, and let's change test. Yeah, we can use 2 for this as well. Oh. All right, so now when we used 8, train data loader next took 8%. All right, so that's cool. That's nice. I think you should probably include that as default just to check that everything is working as you expect.
Level description of.
But I do think this is it's a little bit confusing because this doesn't work. So you need to kind of read the documentation. So, kind of a little bit afraid of making videos on PyTorch Lightning because they're probably going to be outdated in like 6 months.
Tune your model.
It seems like that way, at least when they're changing stuff all the time.
Epochs, and when it's done, it will output all the metrics. Train if you has a min or max epochs flag. In certain cases, even though your training looks converged, the outputs generated by your model will continue to improve as you train. In that case, you may want to train for a minimum number of epochs or a max number of epochs and not use early stopping. For example, you could set your min epochs to 10 or your max epochs to 1,000. The defaults on Lightning are min epochs equals 1 and max epochs equals 1,000. Lightning also has a min or max steps flag. You may want to train for a minimum number of steps like 1,000 and train for a maximum number of steps like 10,000. In that case, you can set min steps equals 1,000 and max steps equals 10,000. The steps refer to training steps. That means that if you run 10,000 steps, it will be of training. Even if you have a validation loop in the middle, it won't count towards those steps. You can set a limit on both steps and epochs, and in that case, the steps will take a precedence. Lightning also has a flag called loop in the middle. It won't count towards those steps. You can set a limit on both steps and epochs, and in that case, the steps will take a precedence. Lightning also has a flag called check val every n epochs. The default is to check validation after every epoch. In case that your training epochs only take a few seconds or a minute, it may be overkill to check validation after every epoch. In that case, you may want to check it maybe every 10 or 100 epochs. You can set that flag to equals to 10 or equals to 100 to do that. Lightning has a flag called val check interval. In case that your epoch can take maybe a few days or it's super long, then you may want to check validation within that epoch. You can set that flag to an integer and it will check after so many steps, or you can set it to a float, in which case it'll check for a percentage of that epoch. So if you set it for 0.25, it will check at a quarter of the training epoch. In some use cases like streaming data during production where there is no limit, you may want to check validation every 1,000 steps. So you can set this flag to 1,000. Lightning also has a flag called num sanity val steps. If you have a bug in your validation loop and your training loop is super long, you may not know that you have that bug until maybe a day later. Lightning will run 2 batches of validation before your training starts automatically. You can set it to any arbitrary number like 10 or 100. If you want to turn it off, you can set it to 0. If you want to run the whole validation loop first, you can set it to -1. Lightning has the limit train batches, limit val batches, and limit test batches flags. In the case where you might have an action that happens every 10 epochs or every 20 epochs, you don't necessarily want to wait 20 epochs to see if that action is taken or if it's correct. In that case, you can actually shorten the length of your training loop and your validation loop by setting these flags. For example, you can set it to limit train batches equals 10, and it will only run 10 batches of your training set. You could set it to 0.1 in limit val batches, and it will actually only run 10% of the validation batches. Lightning has a flag called accumulate grad batches. In certain cases, your data may be so large that it cannot fit on a single batch, but your model cannot train on only 1 or 2 examples. A good example of this is ImageNet trained on full resolution. In this case, you can simulate a large batch by doing multiple forward steps, summing the gradients, and then doing an accumulated backward step. To enable this, just set the number of forward steps that you want, and Lightning will automatically handle the rest. So for example, if I can only fit 4 inputs in memory and my batch size is 4, but I need 16 examples for my model to work properly, I can set accumulate grad batches to 4 and it will generate total batch size equivalent to 16. In some cases, you might want to change my model to work properly. I can set accumulate multiple forward steps, summing the gradients, and then doing an model to work properly. I can set accumulate grad batches to 4.
There's something wrong with my setup here. It's telling me there's a syntax error all the time. I mean, that was pretty easy. Yeah, I like that. It's easy. Oh, that's annoying though. Okay. All right. So let's see. We've learned about a lot of stuff now. So we have the fast dev run, overfit batches, profiler, model summary, automatic learning finder, the batch size search, a lot of different stuff. So I think we have pretty good knowledge now of Lightning, and I think we should go back now to our original idea for the stream, which was going to this thing and then go to VAE. So we'll try to convert this here. We'll start with this. So we'll convert this model right here, which is a variational autoencoder, just a simple example. And we'll try to convert this to a Lightning module that does the same thing basically. And yeah, that's the goal. So let us, before we do that, actually, let's take a little short break and then we'll do that. So is there anyone in the chat, by the way? I don't know how this, let's see. Let's see, live stream. If I can put this over here. How long is the delay on the stream, if there's anyone watching? Do you know? Or I guess how do you... Let's see. Okay. Yo. What's up? All right, that's a pretty long delay actually. That's like, I don't know, 5-10 seconds maybe. Yeah, that's a long delay. Wonder if you can try to minimize the delay some way. Yeah, I can talk about the setup. I'm learning about it just recently. So actually, recently I took my my setup and I converted it into a Ubuntu server actually, and I'm now using my Mac. I like working from Mac OS. I like the user interface and stuff. So I converted that to a Ubuntu server, and I have my setup there. And then I wanted to have, I worked from VS Code, so I then used VS Code to SSH into the machine and worked from there. So everything is local to the machine. But I don't know. I liked the idea of having Tmux and NeoVim, where you can just sort of, I don't know, like this is nice. You can just attach, that you can just attach back, and boom, you're back to your workflow instantly. And I don't know, there's something about that and the flexibility of Vim where you can, and remember, this is from a beginner, so I might change my opinion later on, but right now it seems that you can have a lot of flexibility and that it's so lightweight. It's just a text editor basically, but you can add plugins that are exactly to your liking. You can easily change the key maps so that you can have the exact structure that you want. And that's a pro and a con in my view. The pro is that you can over time set it up exactly as you want, and you can become ultra efficient. And so you just do things the most efficient way. The con with that is that it takes a long time to learn, I think. And I think a lot of people don't want to spend, how long time it takes to just set up your workflow, right? Most people want to just done and then get to work. And I agree with that. And that's why I haven't learned about Vim that much. But on the other hand, there's also the argument of, there's also the idea that you might become fast. It might be a learning curve where initially it's a lot slower, but in the end, you're going to save a lot of time. And so you might be less productive for a month or 2 months, but after those 2 months, you'll be better off. So I'm also open to that idea. So I haven't formed my conclusion yet, but so far I like it. And the tmux setup, really all I'm using it for now is just that I have these, like if I exit this, right now I'm local to my machine. And then if I SSH back into my server, then I can just do tmax attach, boom, I'm back, right? And that's super quick. And I like that part of it. And then also just you can customize like how it looks like. You can do boom, you can do like you can drag with the cursor as well, like exactly how I want. Maybe I want to have it like this, and then yeah, I agree, Sergio. Like I like it. Like for me, for example, when using SS, we can check that actually. So if we go to the activity monitor thing, so here, if you're SSHing from a laptop, right? Maybe you care about battery and stuff. So now we can see the power draw is a lot for Safari because I watch a lot of videos and stuff. iTerm, where I'm SSH, is 10. But if I SSH from VS Code, this is going to be around 90. So 10x the power draw. And so you can just imagine that there's a lot of unnecessary compute for what I need from having having VS Code. So that's an argument as well that, it's a lot more lightweight. It's faster. It's faster to load. It's faster to use. It uses less power. Yeah, having all of the stuff in the terminal makes it super portable. It makes that you can set up, if you just save your .dot files, you can basically just save it on GitHub. If you SSH into a new machine, like you're renting a GPU server that has, 8 A100s or something, then you can just git pull your stuff, set it up, have the exact same workflow, and done. I guess that's the same for VS Code though, but it's just really nice. And since you're just using the terminal, you can pretty much work from any setup. Yeah, I actually added that. So I don't think that's, let's see, where is the, let's see. So I did ls.config. Wait. ls. .config .neovim. What? Oh. I think that was I think I added. I'm not sure where I added it though. Core maybe. .config. I don't know where I added it. Not sure. There was I remember I added it somewhere. It was basically you can use the mouse for doing that. It should be in. I thought it would be in options, but I guess not. Maybe that's in a plugin. No, it's in. I don't know. I'm confused over this. I don't know exactly where I would have put it. But yeah, there's like a command that you add somewhere. I'm not sure where it is though. Yeah, sorry, I didn't find it. Oh yeah, maybe, yeah, it should probably be in the tmux config. So as I said, I'm just learning about this, so. This thing, I think, if you add this to your tmux config, set gmouse on, then you can use your mouse to also drag to set it up as you want. All right. Maybe we should try to do this then. So we want to convert this variational autoencoder that is in bare bones PyTorch, and we just want to improve it by converting everything to PyTorch Lightning. So that's the goal, and yeah. Took longer than I was expecting to go through that stuff. All right, so import PyTorch Lightning as PL. We'll create a class. We'll do variational auto VAEPL PL Lightning module. This is nice. Copilot is helpful. So I guess we'll well, okay, wait, that's actually not what we want. But it was a good start. You send in H params here. Let's go back. Not that much back though. So let's do this. We'll want to have our forward. Oh, okay. So wait, you can do this. Okay, wait. I didn't get that before. So you can do forward, self, and x, and then you can just do self of x. Okay. That is nice. That's maybe a better way of doing it. I like that. So let's remove this now and just do pass. We'll do. We should probably send in the h params like this. I don't know how they send it in though. I don't know what this h params is exactly. But yeah, let's do that. So then I will do. This is what we need to copy, right? We need to put that here. Let's see. What? Maybe we can separate them, so we can do self.encoder. Yeah, that's what I was thinking. And then we'll do self.decoder. Yes, relu. And then sigmoid. Can you do this? I guess f.sigmoid. Hope that works. So we'll do the encoder decoder like that. We can remove these. And then we have encoder decoder. We'll do the forward here. Let's see what we did here. So I mean, we separated, right? So we did encode decode, and the forward was this. So I guess we can do that like this. We did forward mu sigma. We do self.encoder of x. I need to remember VAs now. So we get an estimation of our mu and our standard deviation, right? I did this video not too long ago. I should remember this. And then we do the trick with the epsilon to make it so that we're able to do the derivation or back propagation, but still be able to sample from a normal distribution. So we do mu plus sigma times epsilon. We do reconstruct it with self.decoder of z, and then we'd get x reconstructed mu and sigma. That's our forward. So now for the training step, right, we will do, let's see. So we need to open up maybe, let's see what we do. We do this, and then we'll do a vertical split. We will do a tree here, and we will go back and we will open up our training. We'll move the tree and we'll go down. All right, so we will see what we do in our training setup here, because we will need to do this thing. Oh, that's not what I want. Whoa, go back. Oh, what happened? There we go. All right, so we want to have, from the forward, we want to do our training step. So first we take out X and the label in batch. Yeah, we compute X reconstructed mu and sigma. We will need a loss function. So, okay. Yeah, I guess. Yeah, I guess like this. No. So here we will just send in X reconstructed and X, no mu and sigma. All right, so we have the loss now. This is the reconstruction loss, and we can do the KL divergence, and we can just copy that, I think. So we'll do, all right, so now we have that. That's when we need mu and sigma, and then we just do losses, that thing right there, and we don't have to worry about anything else. Let's just return the loss. And we'll do the similar thing for the validation step. Yeah, like that. This is what I don't like. Like, even if you do this cell forward, all right, that's nice, right? We've sort of structured the code a lot better, but the thing I don't like is that we're still copy pasting code. And what you could do is you could do define one step, and you could sort of reuse that in the training and the validation. Maybe that's the best, but right now, I guess it's okay to have this like this. But when we're gonna do the test step as well, like this, and we'll do this exact same thing. I mean, this is ugly, right? So yeah. We don't have to do self.eval on using PyTorch Lightning. So we don't even have to do to device. As you can see, like we're not sending in the device or anything. That's being taken care of for us using Lightning. So all right, so let's see. We've now done the training step, forward, configure optimizers. We'll just set the learning rate right now to 3-4, of course. And we'll tune it using the tuner, but now we should probably be able to do this like that. And let's do VAE PL. So this is our sanity check. We're just sending in the input that are 4 the batch size here, we're setting in 8 batches. And each is going to be an MNIST digit 28 by 28, I guess by 1. And then we initialize the PyTorch Lightning module, we send it in, and we get that the shape should come back correct. So let's try that, and we'll do quit on this, and we'll go back to our setup. So we'll move now to more advanced, and then VAE, and then Lightning, and we'll do Python model. Right, we don't have H params, so we'll remove that. We'll learn how to do that later. I don't know how to do that now. Input dim is not defined. Let's do input dim. Should be 784, like that. I don't think that's correct though. Let's see. What did we use before? So we'll open up this. Yeah, we'll do hidden dim to be 200 because that's what we did before. That's nice. And then we'll go back, run it. HDim is not defined. What? All right, it should be HDim. And it is called something else, latent dim. Let's see, nvim model.py, zdim. Yeah, I was worried about that. So here, I guess we could do self.sigmoid is nn.sigmoid, and then just remove this and do self.sigmoid. That works probably. F linear could not multiply. Self.encoder of x. So it's here we're getting the issue. Self.encoder of x. We're running it through, first of all, we are print x.shape. We might have to change the shape of it because it might not be. No, it's 784. Our input dim image to hidden is 784 to 200. Then we do a relu. Then we do hid to mu. Right, maybe it shouldn't be this way actually. Let's see. Yeah, I will post on like the goal for the stream is just to it's just for fun, right? This is just for fun. Share my process of when I'm learning this thing. But you know, as usual, when I feel like I have learned it and have good explanations to give, I'll make more refined, shorter, more sort of structured videos so that it will be easier to follow and less mistakes and so on. So yeah, I'll do that, but that will be after I'm sort of in the learning phase now, and when I've learned it, I'll when I feel I have something that can be useful, I'll share it and make videos on it. What did we do here? So from the encoder, we got mu and sigma. This is why it doesn't work. Right. Yeah. I guess we need to do this. I didn't think of that. So I guess we just need to change this because we can't do it. That's fine. So let's just copy paste that stuff actually. So encode, decode, we have all of that, and then we'll do forward. We'll change this to mu and sigma is self.encode. We don't have to do view here, I think. And we can do an assert. Self.encode. We will do x reconstructed here like that. And yeah, that's it. So let's see. Yay, it works. Let's go. Yay. So we printed, what did we do? We printed x reconstructed shape. Yeah, so this we expect to be 784. I guess one thing is that we do want to actually do x.view here. Because, you know, we can make this general though. So input dim is input dim. We'll go down to there we go, and we'll do self.input dim. All right, so we have set up the model now. We've just done a simple sanity check. We can run it through a batch, which is a good first step. And so it seems like we've converted the model now. I guess we need to also, let's see how the train looks like. So we've also done this, right? We've done x.view. We've done the reconstruction, the model. We've done the loss, and the backprop should be for us, so we don't have to worry about that. So we can just remove these things now. We don't need to do model.toCPU. We can create a separate data loading as well, as we did previously. So I guess we can do that. Let's do touch. I don't know what we should call it. Dataset.py. Dataset. And here we will just take whatever we did before. So let's see. We did nvim back. Let's see. Yeah, so this is what we did. We will take this mnist. There we go. We'll copy, take it, copy, put it over here. I need to add, what are they called? Like a flake 8, and so that you can see which imports are unnecessary and stuff. I don't have that right now, but I will add that. I also think, I wonder what, I just realized, like, one of the things is that when I do B like this, it formats the code, right? But I wonder why I'm getting syntax error is because the spacing is not the same. So like in my black might use black default space, tab space, 4 spaces. So what is it? Indent size, 4 space. So when I think about it, it might be that if we go to just here, config nvim lua, and we should go to core options. I think this should be 4 here for me. I've set it to 2, but it might cause errors. So let's try that. All right, so yeah, you see syntax error. We'll see. So we'll just add all of the stuffs now. Yeah, I'm having some issue with this because like I don't think there's a syntax error here, but it's saying that it is. So I don't know what that's about. I mean, we can try and run it. Yeah, see, there's no error. And if we open it up again, it's fine. And if we do black, maybe I just need to reload it. I'm not sure. All right, so we have the MNIST module. We set the batch size here. This should not be like this. I know it shouldn't be, and also for the learning rate, but we'll change that later. So we'll just set the batch size like this. Yeah, we'll do it the same way as we did before. So this should be, let's see, batch size 32. All right. Check that it works. I didn't know this. dm.setup fit. Yeah, okay. Cool. All right, so we have the data module now. Obviously, we have a lot of stuff here that isn't needed. We don't need metrics. We don't need TQDM. We don't need data loader here. And we don't need this. We don't need that. We don't need this. All right, cool. All right, so now we have the data set. We have the, now we just need to redefine the training stuff. Cool. So I guess the data set loading should not be like, we'll do from data set import, what was it called? Oh, that's not what I wanted. And we will do, so we have the data set. We'll also do from model. And we called it, what did we call it? Here, down there. We'll do nvim model. We call it VAPL. PL. Cool. So now let's do, we're not going to do the data loading. right? We won't do pretty much any of this. We'll do model equals VAPL. That's it. We'll do data module is MNIST data module. That way we can remove this, all of this stuff. So we'll do loss function. I guess we need to send in the loss function. We didn't do that. And then the training, we don't have to do this. The inference step we can keep, right? This is still nice. But we'll make sure it doesn't run for now. Cool. So we have a loss function, DM. We'll do let's see. We did in the train. No, sorry. In the model here, we sent in the loss function somewhere. Loss function, where are you? Loss function. Loss function, self.loss function. So we need to send in the loss function here. Let's do that. This is not the way to do it. I know it isn't, but let's, this is bad, but we'll do it like this. And I guess we need to go down loss function. There we go. All right, that's probably good enough. So let's go back, boom. And let's do now the training and stuff. So we have the loss, we have model and data module. Now we will do all the stuff that we did before. So let's go back to our basics. In our basic, we did where is it? Lightning. There it is. Lightning, and then we did all of this stuff. MNIST module. There we go. So we'll do if name equals main. We'll do trainer equals pl.trainer. And we will start with doing max overfit batches, 10 or 1. And we'll do accelerator GPU, devices 0. Enable model summary. We'll do true on that. And is that it? If this works, I'm mind blown. Like, that was, it's not gonna work though. It never does. 22, remove that. VAPL has no attribute loss function. This is what I mean before, by the way, when we did, like, it should be in one step. Like, I don't see the point of having it like this. Same code all over the place. It's exact same code. I mean, I know that you want to have it, you might potentially want to have it different because here you're going to do log that, like some stuff, and you might do logging and other stuff. But yeah, I don't know. Okay, we are in this. We want to go to the original train. No. I just lost what I wanted to do. I wanted to fix the error, which was that the shapes were not correct, which is in this. Oh, we removed it? No. Come on. No, 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 no. Oh, I can't believe we removed it. That's a mistake. Yeah, I must have removed it. Oh, Jesus. At least it's on GitHub. I'm a bit confused because I didn't reshape it before. So we did a reshaping before we send it in here, but then we didn't from my understanding, we didn't reshape the target anything. Okay, not sure what that's about. So we're getting the error here. Print x dot shape, print x reconstructed. bit lost. I'm not sure what's wrong. So in the forward step is where we are changing the size, but we're computing. It should print here, I feel like. Or it's not here, that's the error. If I'm doing, it should definitely stop running here. See, it's error instantly. Okay. Right now, I am trying to convert sort of bare bones PyTorch code that is for a variational autoencoder. I'm trying to just rewrite it using PyTorch Lightning and see how that looks and compare it basically to see if it's better. But I'm getting a bit tired, maybe. I don't know. I feel like I don't know what's the problem here exactly. We are getting error when computing the loss, and we're computing the loss somewhere here. So let's do, I don't know, what if we do this? We just do remove these like that, and then okay, so it was doing something else there. Okay, so here we got x.shape, which is, wait, what? Oh, I'm tired. Makes sense. So we're doing it in the forward, right? But it should definitely be in the training step. Here it should be, right? Because we're doing the batch, we're doing the thing where we're converting it, and then we're doing forward, and then we're computing the loss here. So we need to keep it on that same, right? So that makes sense. Cool. Now it works. Nice. So I guess we can take it back now. Let's see. Oh, that was a mistake. 15K. There we go. And then we'll just take that right there. We'll put it in between here, and same thing over there. Like that. All right, cool. Now we have train step, val step, test step, and we should be good to go if we go to the training. All right. This is our entire setup right now. So you can ignore this thing, just ignore it. And here's what we're doing. So we've implemented the model. We converted it from bare-bones PyTorch to VAE using PyTorch Lightning. And we did a data module with MNIST data module, which is a Lightning data module, I think. And then trainer. Now we want to first overfit a single batch, because that's what you do. And then we should be able to run it now. Cool. And I guess this is not that great though. You see the loss is very slow. But yeah, it's decreasing. This might tell us though that the hyperparameters are not that good. But yeah, it is kind of working. Not that great though. So we can do, let's see what we can do. This is kind of the problem here though, because Yeah, this is not how you should do it ideally. If we go here to model, here I'm sending in, no, I'm not doing it here, I guess. Here we are. In the optimizer, we're sending in the learning rate. This should not be done here, or at least it should be like this, where we will send in the learning rate here. And then we'll do learning rate equals self.learning rate, like that. And that's an improvement. And then train here, we want to set the batch size somewhere as well. I guess that's in the data set. Batch size. So here we should do self.batch size. That's good. And then, yeah, that's good. So we'll do train. We'll change this first. So we'll do maybe overfit 16 batches, or do auto learning rate find true. Oh, 0.01. Yeah, that's different. So we'll try to do that. We can do this and overfit a single batch again. If this is if this works, then it's nice. The auto learning rate finder is actually helpful, but it is taking a while. Not sure what that log thing is. Log every n steps. How often to log within? All right, cool. Yeah, I do think it's faster now. Yeah, it's a lot faster. All right, this was a better learning rate for sure. All right, cool. That's nice. So that works. Maybe we can now do auto batch. So this is what I did before, where I put this thing first. So we first start with scaling the batch size to what we want, like this. And then it will basically tell us, all right, 1024 succeeded, all of that succeeded. And I guess if we look at NVIDIA SMI, okay, it doesn't go up, but it should basically tell us the batch size. And it seems like we can use pretty much an insanely large batch size here. And maybe if that's the case, we will try to just use we'll just use like 512 maybe. All right, so because we can use a pretty large batch size, we'll do that in this case. And then we'll do auto learning rate find. We'll remove this. We'll do overfit a batch. I don't know where it says 100 steps, because it's a large amount of steps, I feel like. But all right, cool. I mean, that seems to work. Loss is going down. It's a lot of examples now, or I mean, maybe a bit slow to converge. But the loss function for the VAE is a little bit tricky, so that might be why. We can set max epochs to 10, and that's it. So then we'll do we'll try it for inference, if this works. I guess saving the image is gonna be tricky, because we're saving it to a local folder. I guess we can do like copy it somehow. Ideally, we would have just had TensorBoard right now and just looked at TensorBoard for the images, but I haven't learned how to do that yet. So yeah, it takes a long time to overfit, but it is going down, so I guess that's a good idea. Now I'm getting a phone call. Hold on, I'll mute myself. All right, I'm back. Sorry about that. I'm waiting for a shipping of a laptop and they are having some issues. But all right, so we got it set up. We need to, I don't remember what I was doing now. I was trying to overfit a single batch. After that, we want to do the debug mode. However, we did that just to make sure that everything works, and then we'll train it. But we need to set it up with TensorBoard, and I think that's the next step. So that's the next goal. But I think I'm happy for today. I need to eat some lunch. And for those joining or joined the live stream, I appreciate you. It was cool. And I'll continue tomorrow probably. I mean, I was thinking, so again, I said this before, but my goal now is just, this is a chill live stream. You see me fail and try to learn it, and you can learn it with me or whatever. And then ask, or if you ask questions and stuff, we can chat. And then I'll do more refined videos in the future on PyTorch Lightning when I've sort of learned it and have something valuable to share. All right, but thanks for today, guys. Have a nice day. Where's the chat? I missed the chat, if there's anyone here. All right, guys. Bye-bye.